All right, we're going to start the lesson on how to graph a polynomial using the different steps. So I'll go through it one step at a time. We'll do a couple of graphs. So let's go with this. This is in your notes, it's page 6, but it says sketch the graph of this polynomial. So whenever you're given a polynomial to sketch, the first thing you need to know is its end behavior. End behavior is where does it start, where does it end. So we found out from when we took down the notes that for us to find the end behavior, the first tip is to find the degree of the polynomial. The first thing is to find the degree of the polynomial. And the degree of the polynomial, it will give us the end behavior. So let's look at this. How do you find the degree of this polynomial? So the degree of this polynomial, if the polynomial is given to us in the standard form, we say that it should be in the of the highest exponent, but this is in the factored form. So let me deviate a little bit. For example, if you have a polynomial of this sort, x minus 2, x plus 3, what's going to happen is, what is the degree of this? Even though this says that it is x to the first power, there are two x's here. So if you multiply it out to get the standard form, this will be x squared plus x minus 6. So it's actually the second degree. But if you look at it in the factored form, it is 1 and 1. So it's basically the second degree polynomial. Same thing if I change this to x minus 2 cubed and x plus 3. Same thing. This is x cubed in this one, and this is just x. So it's x to the fourth. So this is a fourth degree polynomial. So anytime for you to find the degree, you need to look at the highest exponent, but that is in the standard form. If it is in the factored form, you add all the x's together. So this is x to the fourth, x cubed, and x. So 4 plus 3 plus 1. So this is the 8th degree polynomial. And remember, when we talked about the end behavior, there were a few rules. And we said, and I'm going to go over those one more time. If it is an even degree, it will behave like a parabola. Just for the end behavior. Behaves like a parabola for end behavior only. No, it won't behave like a parabola for everything, but just for end behavior. What does that mean? That means an even degree could be x squared, x4, x6, any of those. For the end behavior, it will behave like a parabola. That means if it is positive, like x squared, positive leading coefficient, where does the parabola? It's up and up, right? Normally a parabola looks like this, but if it's a multiple, it will have multiple x. I don't know how it will behave in between, but the end behavior will be just like a parabola. It will start here and it will end here. And if it is a negative leading coefficient parabola, it will start here, end here, normally like this. But if it's got multiple x-intercepts, it could behave. So I don't know what happens in between, but I know the end behavior of a even degree polynomial will behave like a parabola with up and up and down and down. Okay, now let's look at if it's an odd degree. If it's an odd degree parabola, it behaves like the simplest odd degree function, which is x1, x cubed, and so on and so forth. The simplest one is linear. Again, only for end behavior. So how does an odd degree x cubed, x fifth behave? If it's positive, if the leading coefficient is positive, it's going to start here, end here. I don't know what happens in between. It could even just be a straight line, but it starts here and ends here. And if it is negative, it starts here and ends here. Again, don't know what happens in between, but that is what you're concerned about is the end behavior. Where does it start, where does it end for positive and for negative? So that is your scoop about what the end behavior of a polynomial is based on the degree of the polynomial. So this is an 8th degree polynomial. Okay, so that's the first thing you're going to find. Based on that, you're going to find the n behavior. Based on that, you're going to find the n behavior. So first of all, this is an 8th degree polynomial whose leading coefficient is, I don't see any negatives on this x, so it's going to be a positive. So 8th degree positive behaves like a parabola because it is even degree. So it's going to start in this quadrant. I don't know how it's going to behave in between, but it's going to end in this because it's going to be up and up. Positive parabola starts here, ends here. We just talked about that. Right? So I have my n behavior. Okay, that's taken care of. Next I need to find the x-intercepts. Next time, because I need to know once you find the n behavior, how it behaves. For that I need the x-intercepts. Not only do you need to write the x-intercepts, you need to identify the x-intercepts, you also need to know the multiplicity. And we talked about the multiplicity. Multiplicity is how many times does each factor occur. So, for example, the first one occurs 4 times because to the power 4, cubic, and the first power. And that helps us decide how it's going to behave on that particular multiplicity. And we'll come to that. So before we find the x-intercepts and the multiplicity, let's make sure we know the limit. Limit of this particular function as x is going towards infinity. As x is going towards infinity, I see my graph going up. So that's going to be positive infinity. And as x is going towards negative infinity, again my graph is going up. So it is again infinity. Okay. Next I need to list my x-intercept. But I also need to list whether it crosses or touches, but that comes from the multiplicity. So let's go ahead and write down our x-intercept. So my first x-intercept is from x minus 2. It's positive 2, 0, right? We know how to write the x-intercept from the factors. You take the opposite side. And the multiplicity is to the 4th power, 4. My next x-intercept is from here. It's negative 1, 0. My multiplicity is to the cube, so it's 3. And my third one is 1, 0 is my x-intercept. My multiplicity is 1 because there's no exponent, so it's just 1. What do these multiplicities tell me? It tells me if it is even, okay, so let's write this down over here. If the multiplicity is even, it behaves like a parabola, so it touches it. This is called the touch. Because, whereas if the multiplicity is odd, like a linear or cubic, they're all odd, it crosses it. This is crossing it. And that's what basically we need to know. So basically, 2, 0, my multiplicity is 4, it's even, so it will touch it. Negative 1, 0, multiplicity is 3, it's odd, so it will cross it, but it's cubic. It crosses with it's a cubic, so cubic has a little bit of that turn. And the last one is 1, 0, the multiplicity is 1, so it is linear. So it will also cross it, because linear, cubic cross the x-axis, and this one is turns around. So what we are basically turns around. How does it behave at that x-axis? How does it behave at that x-axis? So we have listed our x-intercepts with the multiplicity, whether it touches it or crosses it. And one more thing we need to find before we start graphing is the y-intercept. And how do you find the y-intercept? Y-intercept, for any polynomial, algebraically you find by setting x to be equal to 0. That's a standard way of finding the y-intercept. So basically, let's find for this particular equation, my y-intercept, you set x to be 0, so y equals to 0 minus 2 to the 4th power, 0 plus 1 cubic, 0 minus 1. I'm sorry, so sorry, yeah. Right, you take the equation, substitute for x equals to 0. So negative 2 to the 4th power is positive 16, because to the 4th power 1 negative 1, so it's going to be negative 16. That's the y-intercept. But whenever you write the y-intercept, you have to write it as a coordinate. X is 0, y is negative 16. Yeah, we're good? So let's go ahead and mark the x and y intercept on our graph. So there is, on the negative x-axis, there's negative 1, 0, and it crosses it with a cubic, because it's cubic. Next is 1, 0, that also crosses it, it's linear. And the last one is 2, 0, it touches it. And my x-intercept is, it'll be below, negative 16 will be down because, but you know, let's just, the scale is not right, but let's just put negative 16 here. Okay, now we're ready to graph. So it starts, we know the starting is here, and it basically, the graph will go from the starting point from one x-intercept to the next. So it'll come to the first x-intercept, which is negative 1. You have to pay attention to it whether it's crossing or touching. It crosses it, and it's cubic, so it'll cross it with a little bit of a curve, because we know cubic is like that little snake on the thing. So it will come to here and give it a little bit of curve. And cross the x-axis. You need to cross, that's why the C. It crosses the x-axis. C stands for cross. Cross. C and or touch. T stands for touch. It crosses it, and when it comes down, it has to touch the y-axis somewhere, so it touches at the y-intercept at negative 16. It will have normally gone way below, but you're putting negative 16 here. And then from here, it will go to the next x-intercept. But just pay attention to what it's going to do at that x-intercept. It's going to cross over, because I've set a C there, it crosses here. And then from this x-intercept, it needs to go to number 2. It will turn around somewhere in between. We're not exactly sure it turns around, because then we need to know the actual behavior between 1 and 2. So it will just turn around. And what do I say at 2? At 2, it touches it. Touch basically means this. So it's going to come and go to 2. Touch it means it turns around and it ends here, which is correct, because I want it to end in this quadrant. So your graph is ready, and this is how you, as long as you follow all these steps, you will be able to graph a polynomial.